In this part of the video, I'll be showing the results of the experiments for each of the three modes: local, atomic, and non-atomic. The first one is for atomic mode, which is the default for each client. As you can see here, the experiment in atomic mode took 6 seconds. The reason it's so short is because in atomic mode, we stop tracking the time once we're done sending our 1,000 messages from a client. And then the client actually finishes executing those after it receives a message from the server. So when it finishes receiving all of them, that can be several seconds after the experiment finishes. So next we'll set local processing to true and see how long that takes. As you can see, only one client is moving because we're in local processing, and that client is the one I just set to local true. The two other clients are having no interaction with the first client. And at the end here, we can see that the experiment took 22.77 seconds. That's because it takes the entire time for all of those commands to be submitted for us to finish our experiment, which in this case is much slower than actually sending the commands to the server. This is probably because there's a GUI involved. So next we're setting local to false and atomic to false to see what non-atomic broadcast looks like. So the total time the non-atomic took was 40 seconds. And the reason it took so much longer than the others is that we're interleaving sending the messages with executing them. Next I'm going to show how the state of each client is set and communicated across the distributed system. So first we're going to set atomic to false, and as you can see, that triggers the set atomic method for this client. And if this atomic is equal to true, we set our broadcast mode to atomic, otherwise we set it to non-atomic. And if we set it to atomic, then we set the connected to the simulation as false, so that we can not immediately execute commands. Whereas if it's non-atomic, we'll set the connected to simulation to true, so that commands are executed when they are received. And you can see that it's broadcast into the console that atomic broadcast is now false. So when we input a string as our command in the first client, we'll see that now we're in client launcher 2, and we're changing the mode there. So that's because the way I set it up is that when the mode is attached to the message that is sent. And each of these arguments, when they are received to each client, they have a field for their broadcast mode. And this broadcast mode is used to update the mode of the client if it's different, and then also decides how the command is executed. So these command objects that are how each client executes a command it receives from another client contain the state that they should be executing in, based on the state of the client it was sent from. And that way, if we execute a command on one client when it's a non-atomic, but then receive an atomic command from another, we will update the state after we've received, or after we've already executed our non-atomic command, because the state is stored in the command object. So you can see here that when we are in non-atomic, we execute the command, and then we send it. And if we change our atomic to true, and you can see again that we're updating the state for the client that we're in, and now we go move to send a command to the other clients, you'll see that the command is sent, and then the execution, when you see command move, is actually after it is sent. You also see that we're updating the state again of this other client where the command was received, and creating a new command object there that contains the execution mode for the received command. And you can see here that we receive the command and execute it in another client. and the difference between a non-atomic, where we execute the command and send it, right here, compared to the atomic mode, where we input the command, send it, and then execute it.